problem 8 in chapter 12 says a 100-gram ball and a 200-gram ball are connected by a 30 centimeter long massless rigid rod. So we got a 100-gram ball. We're going to call this M1. This is the one that's 100 grams. And then we're going to have a bigger one over here, which is 200 grams. And they're connected by a rod, which is 30 centimeters long. And the rod is massless rigid rod. The balls rotate about their center of mass at 120 revolutions per minute. So omega is equal to 120 RPM. We want to know what is the speed of the 100-gram ball, or in our case of M1. All right, so what they said is the thing is spinning, and it's spinning about the center of mass. Well, first we have to figure out where the center of mass is. Now it's going to be closer to the 200-gram side, so the center of mass is going to be here, and it's going to be spinning. We know omega. We want to find V, but V is equal to omega R. We already have omega, but we have to multiply it by the radius to figure out what V is. So we first have to figure out what R is, and R is always going to be the radius, or the distance from the rotation point. So the rotation point is going to be here, where the center of mass is. So we've got to figure out the center of mass. So in this case, you can choose how to do it. The easiest way to do it is to figure out, okay, I'm going to make my reference point. This is a one-dimensional thing. It's all in a line. And I'm going to make my reference point the center of mass 1. So then I'm going to say, well, M total times the x center of mass, there's only x direction, right, is going to be equal to M1 R1 plus M2 R2. But M1, remember this is M1, this is M2 over here. M1 R1 is 0, so that goes away. So the x center of mass is just going to be equal to M2, which is 200 grams, times 30 centimeters, all divided by the sum of the two, which is 100 plus 200. Okay? And if you calculate that, you're going to get that, well, notice that this becomes 300. 300 is just 2/3, right? Or you're going to get 20 centimeters. So the center of mass is 20 centimeters from M1. Or 10 centimeters from M2. Which makes sense because this is half of that, right? So it's got to be closer to this side over here. So we get that the center of mass is at 20 centimeters, but we got to plug it into this equation. But remember, this equation is very specific. R has to be the radius, right? Omega has to be in radians per second. And we want this to be in meters per second. So we got to convert R to meters. So if I convert this to meters, this becomes equal to 0.20 meters. Yeah. And then omega, I got to convert from 120 revolutions per minute into radians per second. So I got 1 minute on the top is 60 seconds on the bottom, and 1 revolution on the bottom, and I have 2 pi radians on the top. So the revolutions cancel and the minutes cancel. So I'm going to multiply by 2 pi and divide by 60. When I do that, I get that omega. Oh, I didn't calculate what omega is. Hold on one second. Let me calculate what that is. So 120 times 2 times pi. Whoops. Try again. Times pi divided by 60. I messed it up. 120 times 2 times pi divided by 60. I get 12.56. 566. All right, so that's omega. So V is equal to 12.566 times 0.2. And I get that V is equal to 2.5 meters per second. We only have two significant figures. And that's what you get for number 8. Now, this is moving at 2.5 meters per second, but this one's not going at 2.5 meters per second because it is significantly closer. In fact, it's going half that speed because it's half as close. Right? Omega is still going to be the same, but it's going to be multiplied by 0.1 instead of 0.2. All right, that's it for number 8.